we are moving to the structure of amines. What is the structure of amines? See, normally, as I told you, what is the structure of ammonia molecule? They have a pyramidal shape, right? Ammonia molecule have a pyramidal shape. Pyramidal. Ammonia molecule have a pyramidal shape. Then amines are obtained from ammonia by replacing one or two or all the hydrogen atoms with the alkyl or aryl group. As I told you, means one of the hydrogen is replaced by some R group. R means aryl or alkyl, any of the group. The nitrogen atom of amines is trivalent and has unshared pair of electron. What is trivalent? See, in case of nitrogen, atomic number is 7, so the electronic configuration will be 2, 5. So nitrogen need 3 more electrons to complete the octet, right? Octet means the 8 electrons in their last shell. Then only it will be stable. So they have a valency of 3. That's why the nitrogen atom, we can call it as nitrogen atom of amines is trivalent. Nitrogen atom of amines is trivalent and has unshared pair of electrons. Okay. Amines are obtained from ammonia by replacing one or two of 3 hydrogen atom with alkyls or aryl group. As I told you, the nitrogen atom of amines is trivalent and has unshared pair of electron. The same thing. Okay, understood. See this one. This is the molecule. So in this ammonia molecule, 2 electrons are there. So as I told you, the hybridization of nitrogen here is sp3 hybridization. The hybridization of nitrogen in ammonia is sp3 hybridization. What is sp3 hybridization? I will show you how you are getting the sp3 hybridization. See, nitrogen. What is the subshell electronic configuration? 1s2, 2s2, 2p3, right? See, we are going to discuss about how the nitrogen atom in the ammonia is getting sp3 hybridization. So I am going to draw the box diagram. See, 1s2. This is 1s orbital. Then next one is 2s2. The next one is 2p3. 1s2, 2s2, 2p3. So listen, here in case of ammonia have to make 3 bonds with each hydrogen, right? Means 3 bonds they need. With each hydrogen they will form 1 bond. So in case of nitrogen, before making bond with the hydrogen normally have 1s1 configuration. We know hydrogen is 1s1. So 1 electron present in hydrogen is present in the s orbital, right? S orbital have a spherical shape and that 1 electron is present in the s orbital. Okay, then before making bond with the hydrogen, what will happen? See, only the valence shell electrons will participate in bonding. So in case of nitrogen, only 2s and 2p subshell electrons will participate in bonding. Only 2s and 2p will participate in bonding. Understood? Then see, here 2s and 2p means 1s orbital and 3p orbital, right? So before making bond with the hydrogen, these 3 orbital will mix together. I think this one you studied in grade 11, chemical bonding, right? Yes. So 1s orbital and 3p orbitals will hybridize to produce sp3. What this 3 indicate? 1s orbital, 3p. Got it? sp3 hybridized orbital. Then how many hybridized orbitals will form? The number of orbitals undergoing hybridization is equal to the number of hybrid orbital formed. So here 1s and 3p means how many orbitals will form after hybridization? In case of nitrogen, you can see this one. 1s and 3p orbital. Now these orbitals are not s or p. It is sp3. The second one is also sp3. Third one is sp3. And the fourth one is also sp3. Got it? So all these orbitals are sp3 hybrid orbital. sp3 hybrid orbitals. But the problem is, in one orbital you can see 2 electrons. In other 3 orbitals you can see 1 electrons. Okay, so that's why in case of nitrogen, see this sp3. So I am representing this. See, s orbital have a shape of spherical, p orbital have a dumbbell shape. Then what will be the shape of sp3? Normally, the hybridized orbital we are representing like this, right? This is the hybrid orbital. So in case of nitrogen, here 4 hybrid orbitals are there. We are representing the 4 hybrid orbitals with this one. Okay, 1 electron, 1 electron means this is 2 electrons. Then 1 here, 1 here, 1 here. Then nitrogen have to make 3 bonds with the hydrogen. So 1 hydrogen will come here with 1 electron. Each hydrogen have 1 electron. So they will make bond here. Next hydrogen will make bond here. Next one will make bond here. Okay. So this is the bonding. Nitrogen covalently bonded to hydrogen 3 bonds. Then here it is the lone pair. Okay. That's why the nitrogen atom, we can call it as it is sp3 hybridized orbital. Okay, so if it is CH3, the same process will happen. Then what is this dashed line and the solid line? Dashed line is below the plane. The solid line is above the plane. And this one, this line is in the same plane. Because this is trigonal pyramidal geometry, or they have pyramidal geometry. We can simply say they have pyramidal geometry. Okay, so this is the structure of ammonia, same to that of the amine. Okay, so in the nitrogen atom, in ammonia, the nitrogen atom is in sp3 hybridization. Very, very important. Okay, got it. See, then here, what is the bond angle? This 180. Okay, clear, right? Yes, this is the structure of amines. How we are drawing the structure of ammonia, normal ammonia, same way we can draw the structure of amines. Because amines means we are replacing 1 hydrogen with 1 alkyl group, right? Yes. Then next one question. See, what makes an alkyl amine more basic than ammonia? Then see, what is the base? See, different theories are there regarding acids and bases. According to Arrhenius theory, acids are H plus donors and bases are OH minus donors. According to Lewis theory, acids are H plus donors and bases are according to Lewis theory, acids are electron acceptors and bases are electron donor. According to Bronsted-Lowry concept, acids are H plus donors and bases are H plus acceptors. Okay, so in terms of electron, we can define acids and bases by Lewis theory. So that is called Lewis acid and Lewis base. So according to Lewis theory, Lewis base, what is a Lewis base? Lewis base means they have tendency to donate the electron pairs. And according to the same theory, acids have a tendency to accept the electron pair. Okay, so in case of ammonia, you can see there is 1 pair of electron, that is lone pair. Why it is called a lone pair? Lone pair means that electrons are not participating in any bonding. That 2 electrons are free, right? They are called a lone pair of electron. These lone pair of electrons are free means they are available to donate. You remember the coordination compounds, right? So in coordination compounds, I told you ammonia can be used as a ligand. Why it is used as a ligand? In ammonia, there is one lone pair, means 1 pair of electron is there. That pair of electron is available to donate to the vacant d orbital of the metal atom or the hybrid orbital of the metal atom. Then that's how they are forming the coordinate bond with the metal, right? That is the coordination compounds. Got it? So here, in case of ammonia, it is a basic character. There is a basic character in ammonia. Why there is a basic character in ammonia? Because in ammonia, nitrogen atom can give, they have a tendency to lose these 2 electrons. That is the unbonded electron. They are the lone pair of electrons. Got it? Yes. But the question is, What makes an alkyl amine more basic than ammonia? Comparing to an alkyl amine, suppose I am taking methylamine. Methylamine means C. I am replacing one hydrogen with the CH3 groups. No other changes. Okay. Then, see, if you are comparing the basic property of these two compounds, this one will be more basic. Which one? This methylamine will be more basic comparing to ammonia. Ammonia is still basic, but comparing to ammonia, if you are replacing one hydrogen with a methyl group, it will be more basic. Why? Because the alkyl groups are plus I groups. Alkyl groups are plus I groups. They have plus I effect. Plus I effect is also called a inductive effect. Inductive effect. What I mean by inductive effect or plus I effect? Electron giving effect or electron releasing tendency. If a group have a tendency to release electron, that is called a plus I effect, or that group is called a plus I group. Got it? If a group have a tendency to release electrons, if a group have a tendency to give electron, donate electron, that tendency is called a plus I effect or plus inductive effect. And the group which have a tendency to release electrons are called a plus I group. Okay. Then, due to the presence of, see here, what are the plus I groups? Alkyl groups are plus I group, I told you. Means if an alkyl group is there, that alkyl group have a tendency to donate electrons. So, listen, in case of hydrogen, that type of effect is not there. Leave it. If an alkyl group is there instead of hydrogen in ammonia, that is called amine, I told you. So this alkyl group have a tendency to release electron. They have a tendency to push their electron, release their electron, donate their electron towards this nitrogen. Already nitrogen have one lone pair of electron. When the CH3 group is giving electron pair, the electron density on this nitrogen atom will increases. When the CH3 group is giving electrons to nitrogen, the electron density on this nitrogen will increases. So what will happen? Already nitrogen have more electrons. When the CH3 group is again giving electron, more electron density on the nitrogen atom, and they have a tendency to give that electron pairs. They have a tendency to lose that electron pairs. According to Lewis theory, electron donors are bases. So when an alkyl group is there, that electron donating power of these amines will increases. When an alkyl group is there, that electron donating power of this nitrogen, because already they have electron, so more electrons are concentrating on this nitrogen, means they have to leave that electron. So the electron releasing power of this nitrogen will increases. It will increases the basic property of this compound. Got it? That's why these alkyl amines are more basic than ammonia. Understood? So this is the reason why comparing to the normal alkyl amines, ammonia is less basic.